All right. So tonight, welcome to anybody who is watching this recording. Happy Tuesday. That's what it is right now, Tuesday night. We're talking about adding in fractions with the same denominator. And the rule, if I was going to say that there is a rule, okay, is that you have to have, you can add this to your notes if you want, you have to have the same denominator, okay? So I'm just kind of writing that down, that you have to have the same denominator. That's the rule. You can't just start adding fractions that have this different denominators. Now, once you do have the same denominator, then you're all ready to start adding. Okay, so I'm going to give you a little simple example right here. I've got the equation 2 sevenths plus 3 sevenths. Okay, since we're adding sevenths, the same denominator here, so I've got the same denominator, we can add. And so what we do is we keep the denominator the same, okay, because we're adding sevenths up, and we just add our numerators. 2 plus 3 is 5, okay? And then in that case, of number 1 here, that's the answer, 5 sevenths, okay? 2 out of 7 plus 3 out of 7 gives us 5 out of 7 pieces, in a sense, okay? So the next thing I want to say about adding and subtracting fractions is I want to highly advise you, if you can, especially if this is like new to you, or you're like thinking, hey, Tim, I'm flexible to do it either way. To do it vertically like this. Do you see how I've got 2 ninths plus 3 ninths over here, and it's like this vertically? The reason why I do that is if I was adding 29 plus 39, I would do it vertically like this, wouldn't I? I would add up the numbers vertically. 9 plus 9 is 18. I'd carry the 1. 3 plus that is 6. Okay, so I'm going to let somebody in the room here. We'll let Nathan in. So that's the basic. Good evening, Nathan. I'll let you go ahead and turn your camera off, Nathan, so we can continue recording this, if you don't mind. So that's the basic rule, is that when you're adding fractions, I would really encourage you to make it vertical like this, rather than works across like this. And for the reason that the reason is because when we add fractions, we do it vertically. And also the second reason is when we start getting different denominators, I think it makes it simpler, which we're going to get into here in a few moments. Okay. So again, the basic rule is that once you have the same denominator, you can start adding. Just keep the denominator the same and add the 2 numerators. So in my next example here, example number 2 here on the screen, I have 2 ninths plus 3 ninths. Since I have this same denominator, I'm ready to add. So I'll just bring down the 9, and I'll add 3 plus 2 and I get 5 ninths. And the last question I always ask myself is, can I reduce 5 ninths at all? And the answer is no, that doesn't reduce at all. Okay. So again, I bet you guys could do number 3 now. In fact, why don't you try? I'll give you the next 10 seconds to do number 3 and 4, and then we'll talk about them. Okay, that's about 10 seconds, okay? Number 3 should have been relatively easy. You're looking at it, you're going, okay, I have the same denominator, so I'm going to bring that down. And then I'm just going to add my numerators and get a 4. And the last question I'm going to ask myself is, can I reduce that at all? No. All right. Number 4 here might have seemed like a little bit of a curveball. I'll show you what I would have done. Because I'm adding, You see that these are mixed fractions, 4 and 2/5, 3 and 1/5, okay? Because I'm adding, I can just add the whole numbers and write the answer nice and big here, okay? That's a 7, 4 plus 3 is 7. And then I'm looking at my numerators and denominators here. Oh, I've got the same denominator, so I can bring down the 5. Hopefully you guys can see this at the bottom of your screen here. And then 2, add my numerators. 2 plus 1 is 3, okay? So there's my answer, 7 and 3/5. So that is adding when you have the same denominators. So if I said to you, take 2/5 plus 1/5 at this point now, you should be going, okay, teacher, I think I got it. I see I have the same denominator. I'm going to bring down that denominator. I'm going to add my numerators and get a 3, and there's my answer. Okay. All right, let's take it up a notch. Okay. So I'll give you a moment or two to just go ahead and copy down what you see on the screen, and then we'll talk about it. Okay, our next concept here is adding fractions with different denominators. Okay, so I'm kind of underlining this here, maybe draw a box around it in my notes here. Okay, how do I do that? Okay, how do I add fractions that have different denominators? And I think what I'm going to do is kind of take you on a little aside here for a second. I want you to look at a couple of numbers here. Look at the number 3 and the number 4. Okay. If I ask you, what is the lowest number that both these two numbers, 3 and 4, both multiply into? Okay. What's the lowest number that both 3 multiplies into and 4 multiplies into? Okay. Hopefully you're thinking, okay, well, they both go into 12. Okay. And one way to look at it is look at the two numbers and look at the biggest of the two, 4, and ask, does 3 go cleanly into 4? No. Double 4 to 8. Does 3 go into 8? No. Triple, that really is 3 times 4 is 12. So you can add this to your notes, okay? This is called the LCD. Okay, it's the lowest common denominator. All right, so that lowest common denominator, the LCD, between 3 and 4 is the number 12. Okay, I just want to make sure I'm recording here. Nope, I'm good. Okay. So let me give you a couple more. Let me give you the numbers 2 and the number, let's say 3. If you're just looking at the numbers 2 and 3, and I ask you, what's the lowest common denominator? Okay. Again, what they call the LCD, the lowest denominator that they would both multiply into. Okay. Hopefully you're looking at those two. And one way to do it is just to look at the biggest of the two and ask yourself, does 2 multiply cleanly into 3? No. Double it. Well, that's actually 2 times 3. Yeah. So 6 is the lowest common denominator between those two. Okay. Between 12, 3 and 4, the LCD is 12. Okay. And then I'll show you a little trick one here. What if you had, what's the LCD, the lowest common denominator, between 2 and 4? Okay, I wish we're going to run into this in just a second. If you're really thinking, you're going, what's the lowest number that both 2 go and 4 multiply into cleanly? Well, here's the little secret. 4 goes into itself once. Okay, 4 times 1 is 4. And 2 goes into 4. So the LCD between these two is 4. That's the lowest common number that both these go into. Okay, so I hope I've kind of established what a lowest common denominator is. If you're just looking at two numbers and you're asking what's the lowest number that they both go into. Now, given that, let's jump over here on and take a look at our fractions here. Number 1 here says 3/5 plus 4/15. Okay, if you remember back on the previous slide, If it was 2 9s plus 3 9s, we could go ahead and add because we have the same denominator. We have a rule. It's got to have the same denominator. But number 1 here, we can't do that. We can't add 3/5 plus 4/15 because we have a different denominator. So what we're going to do is we're going to look at these two denominators, okay? 5 and 15. And we're going to ask ourselves, what is the lowest number that both 5 and 15 multiply into cleanly, okay? And hopefully if you're really thinking here for a moment, you're thinking, oh, this is just like the example down here that Tim just gave here, 2 and 4, because 15 goes into itself and 5 goes into 15. So I want you very carefully to follow exactly what I'm doing in your notes. Okay, you'll notice that I have 3/5 equals something over 15. And I've got 4/15 equals something over 15. Okay. All right, Buzzy, I'm going to have you go ahead and turn off your camera, Buzzy, if you don't mind, because I'm recording. Hi, good to see you tonight. Thank you, Buzzy. And camera and microphone. I'll let you turn it on at the end when we ask questions.
All right.
Okay, fabulous. So having said that, now here's the next question I asked myself, and I'm going to choose a different color here. It'll stand out. Now I'm asking myself, this is the way I want you to think it. I got 4/15 equals something over 15 here. Okay, I've written that. Here's what you do next. You ask, what did I multiply the 15 by down here to get to 15? I must have multiplied this times 1. So I'm going to write it kind of small here, okay? 1 times 15 is 15. The same thing that you did to the bottom number that we call the denominator, you will now do to the top number, the numerator. So I'm going to multiply 4 times 1, and I'm going to get a 4. Okay, really 4/15. Wait a minute, did I do something wrong here? Nope, I'm good. I am still good here. Okay, now I'm going to jump up to my top number. Okay, 3/5 equals something over a 15th. Here's the question I'm going to ask myself. How did the 5 get to 15? What did I multiply 5 by to get it to 15? I must have multiplied it times 3. 5 times 3 is 15. That's how that became that. So same thing has to happen to the top. I got to multiply the numerator times 3. Okay? Because whatever I did to the bottom number, I'm now going to do the top. So now 3 times 3 is 9. Now I want you to notice some magic here that just took place here. If I choose a different color, look what I've done now. I've got 9/15 plus 4/15. Oh, the teacher just taught us that as soon as I have the same denominator, I'm ready to add. So I am ready. I'm going to bring down the 15ths, okay? And I'm going to look at my numerators, 9 and 4, okay? And add those two together, and I get 13. And then the last question I ask myself is, can I reduce that at all? No, 13/15 is as low as it's going to go. Okay. All right. Let me do one more before I see if you guys could do one here. Okay. Look at 3/4 and 1/2. Okay. Teacher says, the rule is I can't add till I have the same denominator. I don't have the same denominator, so I'm going to write this equal sign. I really encourage you to do the same because it kind of helps you figure out what you're doing. I'm going to look at my two denominators and ask myself, what's my LCD, my lowest common multiple or number that they go into, okay? Well, 4 goes into itself and 2 goes into 4. 4 is the lowest common denominator that they both multiply into. See how I wrote that? All right. Now what I'm going to do is I'm going to ask myself this question. This 2, how did it become a 4? I must have multiplied it by 2. So I'm going to do the same exact thing to my top number, my numerator, times 2. 1 times 2 is 2. Make that nice and big, okay? The 4 here up on 3/4 equals something over 4. How did the 4 stay 4? I must have multiplied it times 1 because 1 times 4 is 4. Same thing has to happen to the top. Multiply it times 1. 3 times 1 is 3. Now I have 3/4 plus 2/4. I am ready to add. I am ready to add. I can bring down the 4. I can add my numerators. 3 plus 2 is 5. And here's an interesting answer here. I want you to notice, last week we learned about fractions. This is what we call an improper fraction. Improper because the number on top, the numerator, is greater than the number on bottom. We'll change it into a mixed fraction as an answer. So here's what I'm going to do. I'm going to write equals. And to change, as we learned last week, to change an improper to a mixed, we divide the denominator into the numerator. 4 goes into 5 only one time. There's 1 left over, and we just bring the 4 over, okay? And that's my final answer. All right. Let me do at least one more here, guys, because I really want you to see it a couple of times here, okay? So if I choose another color here, let's just go green here, okay? I've got 4/9 plus 5/6 plus 7/18. I cannot add yet. Here's what I do in a situation where I've got 3 denominators. I often will look at the biggest denominator here. Here's my biggest denominator here. And I ask myself, because I know 18 goes into itself once, I ask myself, will the next one up go into 18? Yeah, 6 goes into 18. Okay, so far so good. Will the next one up go into it? 9 goes into 18. Ah, well, it's a good thing I just started with the biggest of the 3 denominators, because that is my LCD. That's my lowest common denominator that they all go into. So please take your notes and do what I'm doing here and write 18 3 times. Okay. And again, I will change colors here. And I'm going to kind of skip writing it all out. Hopefully by now you're starting to get it, but I'll talk it all through. Okay. I'm looking at 7/18 equals something over 18. How did 18 become 18? It's times 1. So 7 times 1 is 7. Okay. I'm jumping up to the next fraction here. 5/6 equals something over 18. I'm looking at my denominator here. That's where you want to focus. What did I multiply 6 by to get it to 18? I'll write it here. Times 3. So 3 times 5 is 15. Okay. And then I'm looking at the top one. What did I multiply 9 by? Times 2. So I must have multiplied this times 2. And I have 8. Now I have 8 18s, 15 18s, and 7 18s. I'm ready to add them all up. So I'll go ahead and add them up here. And I'll bring down my 18. And 15 plus, well, 8 and 7 is 15. So I'm just thinking out loud like a math student. 8 plus 7 is 15, and plus 15 is 30. Okay. All right. That, right now, you're probably hopefully recognizing here, that answer is an improper fraction because the numerator is greater. So I'm going to change it to mixed by asking myself, how many times does 18 go into 30? Well, 18 times 2 is 32. So it only goes into it one time. I'm going to keep my denominator. And what's the difference? Well, 1920 plus 10 is, so that's 12. All right. This is a good example here. Okay. This is a 1 and 12 18ths. Do you remember I started teaching you that when you get your answer, the last question you should always ask yourself is, can I reduce? Those 3 words, can I reduce? I'm looking at 1 and 12 18ths, and I'm looking at this fraction here. And because I know my times tables, I know something, they're both even numbers. I know 2 goes into them both. Biggest number that goes into both of them is 6. 6 goes into 12 2 times, and it goes into 18 3 times. So actually, if you don't mind me my squeezing this all in here, my answer should be 1, 6 goes into 12 2 times, and 6 goes into 18 3 times. 1 2/3 is my final answer. Okay, so that's how you add fractions that have different denominators and that are all just kind of what we call proper fractions. Okay, I'm going to jump to the next slide here and give you about 30 seconds to go ahead and copy this down. Okay, in this next example here, example number 1, hopefully I've given you enough time to write something down and maybe try it. We're just going to look at number 1 here. I'm looking at my two denominators. They're different. That tells me I'm not ready to add. First thing I do is write an equal sign right here. And then I look at my two denominators and I realize, okay, 5 is bigger, 4 doesn't go into it, double 5, 20 is my lowest common denominator, okay? Now, for some of you, if you don't know your times tables in your head, this is one of the reasons why it's so important that you learn them. They're just in your brain, okay? Don't panic. You can use a cheat sheet. You can use whatever you need to try to figure it out, but it really slows you down, okay? Just being honest with you here, okay? Makes it much slower. How did the 4 become a 20? I multiplied it by 5. So 5 times 3 is 15. How did the 5 become a 20? I multiplied it by 4. So 4 times 2 is 8. I'm ready to add. So I'm going to go ahead and add my numbers here. Bring down my 20. 15 plus 8 is 18, 9, 23. Okay. And I'm looking at that. My brain is going, uh-oh, that's improper. Bigger numerator than denominator. So I'm going to change it into a mix by saying 20 goes into 23 one time. There's 3 left over, and that goes over 20. And the last question I'll ask myself is, can I reduce that? No, can't reduce that at all. Okay. All right, so you have a couple more problems. I'll give you a few more seconds to copy these problems down, but I'm going to let you just use those as practice problems and in your notes, literally in your notes. Sometimes the best notes are where the teacher teaches you something, shows you something, and then you do something, and you do it all in the notes. So you see what you did in that moment, because tonight at 10 o'clock or tomorrow at 10 a.m., you might kind of forget, but then you can look at those notes and go, oh yeah, I did this. Okay, here's the one I did. Okay, I got it. Which is why it's so important to do homework in math, because you're practicing until it sticks. Okay. Give you another 10 seconds here to copy the last example here. And then again, later on tonight after the session, you can practice these and have it in your notes. Okay. All right, I'm going to jump to the next slide here. And we're going to talk about, actually, this is just more practice. So don't worry about copying this slide at all. Don't worry about it. I will send this to you in email, okay? But it's just some more practice problems. Some of them are a little bit easier than others. I did throw a curveball at you over here, this number 10 here, okay, that I'm pointing out with an arrow. I wanted you to see one where you have, it's kind of covered up by my thing here, but let's see what happens if I move this out of the way for a second. What I suggest that you do is take all 3 of those mixed fractions and line them up vertically to add them. It's just going to make it so much easier, I think, to do it like that. Okay. Now, I should say something to you. If you're one of those students that you learn how to do it horizontally, and I'm really throwing a curveball at you by making you do it vertically, but you know how to do it horizontally across, you can do that. It's not going to be the end of the world, but sure would be nicer. Okay. Okay, I do want to talk a little bit about reducing fractions. I think I talked about this last week, but I want to kind of review this couple, just reducing fractions, okay, this concept. When you're reducing a fraction like 6/12, here's what you're asking yourself. What's the biggest number that multiplies into both of those? Okay, that multiplies into both 6 and 12. And I said biggest number, okay? You could do 2. You could look at these, well, 2 goes into both of these, but watch what will happen. And it's okay. It's not the end of the world. You're just going to have to do another step. 2 goes into 6 3 times, and 2 goes into 12 6 times, okay? But I'm looking at 3, 6, and I'm going, oh, I could reduce that more because 3 goes into itself once and it goes into 6 twice, okay? So some of you might be wondering, does it matter what if I, if I pick 3 or 2 or 6? It kind of doesn't matter, but you just have to keep reducing until you get it as low as it will go. However, here's why it kind of matters, okay? The biggest number you can pick that goes into them gets you reduced down the fastest, okay? So that's why it kind of matters that you try to figure out which is your biggest number. In the example number 2 here, because I know my times tables, I'm thinking, yeah, 7 goes into 28. So 7 goes into itself once. It goes into 28 4. The last question I ask is, can it reduce anymore? No. All right. I do want to show you this next example because I want you to see a little trick here. It's kind of a little trick. When you have numbers like 20 and 50, you see how they both end with zeros, okay? You can literally do this little trick. If they both end with zeros, and I said and, the last digit to the right is a 0. That's really important. Not if it's in the middle, but if they both end with 0, you can cross it out. And what do you got? You got, that's 2/5. Okay. It reduces down to, that's what's left, 2/5. Okay. Another example is over here on the far right here. What do you do if you had, for instance, 420 over 480? You might be thinking, oh, that's going to take me forever to reduce. But oh, wait a minute, I've got zeros on the end here. I can cross these out. And now I've got 42 over 48. And I happen to know that 6 goes into 42 7 times, because 6 times 7 is 42. 6 goes into 48 8 times, 7/8. Okay, that really helped me to get rid of that 0 there. All right, so that's reducing. A little review about reducing. Okay, now again, I just want to hit you this concept again, because sometimes it helps to hit something twice in the same night. What if you gave you something like this? It's called raising fractions. I've got 2/5 equals something over 20. I'm going to ask myself, how did that 5 right there, how did this 5 become a 20? I had to have multiplied it by, my brain says 4. So whatever I do to the bottom, I'm doing it to the top, okay? Next example, 4 9 equals something over 27. 9 times 3, so 4 times 3 is 12. Next example, 4/5 equals something over 30. I'm looking at the denominator. 5 times 6 got me to 30. So 6 times 4 is 24, okay? So that's just a little review of that concept. I'm going to skip the last example on this slide here. And this is also a review, okay? So go ahead and copy at least the first 2 down. It's changing improper fractions to whole or mixed numbers, okay, mixed fractions. And we were talking about this already, but if you get an answer like 3 over 2, the way you change it into a mixed is you divide the denominator into the numerator. 2 goes into 3 only one time. There's 1 left over, and then you just keep the same numerator, okay? I mean, sorry, the same denominator. I'll just draw an arrow like this. All right. 5 over 2, okay? 5 halves is how someone might say it out loud. 2 goes into 5 2 times. Now listen to this next part really carefully, because 2 times 2 is 4. What's the difference between between 4 and 5? If you subtracted 4 from 5, you get 1, and you just bring over the 2, okay? And then one more example. 21 over 9, I'm asking, 9 goes into 21 2 times. Listen carefully, because 2 times 9 is 18. That number 18 now becomes critical. What's the difference? If I subtracted 18 from 21, I'm just going to count up 19, 20, 21, 3, okay, over ninths. Now, this is a good example here of why I'm always telling you the last question you should always ask yourself is that three-word question. Can I reduce? That's in your brain. Sorry, reduce here. In your brain, I'm trying to train you that when you're working with fractions, the last thing I glance at is, can I reduce this anymore? Oh, yes, I can, because 3 goes into both the numerator and the denominator. So this becomes 2, and 3 goes into itself once, 3 goes into 9 3 times, okay? So that's my final answer, okay? Okay, that's enough of that, just kind of a review of what we've been talking about tonight. And then this is also a review, hopefully from last week, of changing mixed numbers to improper, okay? If they, and by the way, if you're asking, well, when am I going to ever need to do that? Why is that important? Actually, when we get into about a week from now or so, when we start multiplying fractions, you can't multiply mixed. You've got to change them to improper, and then you multiply, okay? So I've got a fraction here that is 2 1/4. To change it to an improper, again, this is what's called mixed because I'm mixing a whole with a fraction. I multiply the denominator times the whole number and add the numerator. 4 times 2 is 8, plus 1 is 9, and I keep the denominator the same. 1 4/7. Multiply the denominator times the whole number is 7, 8, 9, 10, 11 over 4, okay? Or, I'm sorry, over 7. Next one, 15, 16 over 3, okay? You're kind of getting that concept of changing mixed to improper. All right, let's take a look at a story problem or two, okay? I wanted to help you with a couple of these before we left this concept tonight. So if Karen is 62 1/2 inches tall, notice how I said the word and here. You might want to get used to thinking about it like that. This is 62 and, okay? I'm going to change colors so it stands out better. 62 1/2 inches tall. Her mother is 5 3/4. So this is 5 and, okay? Write this like this, 3/4 inches taller. How tall is Karen's mother? This is a story problem. Well, Karen's 62 1/2 and the mom is 5 3/4 inches taller. I'm going to have to add these two fractions together to find out how tall Karen's mom is. Okay, so here's what you're going to do. And here's my biggest piece of advice I can give you for story problems. There's like a couple of really key things, but one of them is take the numbers that you see in the word problem, just literally physically take the numbers and put them on paper. Sometimes once you do that, you're like, oh, I see. I think I know what to do next. Okay. And in this case, I've got 62 1/2. That's how tall Karen is, that tall. Okay. And her mom is 5 3/4 inches taller. So 5 3/4. How tall is the mom? Okay, if I'm adding these up. So what you're going to do is, at this point, you're ready to add. Okay, 62 plus 5 is 67. Okay, I'm looking at my two denominators there, and they are different. So I'm going to say 2 and 4, biggest thing they both go into. My lowest common denominator is 4. All right, because 4 times 1 is 4, so 3 times 1 is 3. I should put my denominator here. 2 times 2 is 4, so 1 times 2 is 2. Add them up, and I'm going to have a 4 here, and I got 3 plus 2 is 5. Now, this is a bit of a trick question here. I want you to look at my answer here. I've got 67 5/4. You see that? That's a 5/4. All right. That is, right there, that 5/4 is an improper fraction. I'm going to change it like we just learned. I'm going to go 4 goes into 5 one time. There's 1 left over, and the 4 carries over. But don't forget, I've got this 67 over here. See that 67 over here? I got a whole number and a whole number there. So it would be, my final answer would be 67 plus 1 is 68 and 1/4. That's how tall the mom is. She's 68 and 1/4 inches. Okay. So 5 feet 8 1/4. All right. Anyway, so, and again, here's another example, and I won't go through the whole thing for the sake of time here. Mrs. Johnson drove 5.5 mile, that should say miles. Sorry, folks. That should be miles. To the supermarket, 7 3/4 or 3/10 miles to the hardware store, and 8/10 of a mile to the laundry. What total distance did she drive? Okay, so I would take that problem and go, it wants the total. It's asking for total. Totally usually means you're adding. Sometimes it'll mean you're multiplying, but here's another story problem hint. So story problem number 1 is if you can, take the numbers and put them on your paper, and it might just help you figure out what to do. Hint number 2, look, this is really important. In a story problem, notice this looks like 3 lines long. You always want to pay the most attention to the very last line that has the question mark in it, because that line will very often have, and here's the third clue or secret, it'll have a key word in it. Okay. Clue number 1, write the numbers on the paper. Clue number 2, pay attention to the very last sentence. And clue number 3 that's related to that is it will often have a key word. Here's my key word in this sentence. It's the sentence that has the question mark. Okay. So that's what it's really asking for. Total often means adding. That's a key word for adding. So what I would do is, in this particular example, I would just go ahead and start adding. I bet you this doesn't even show up. Yeah, well, it doesn't. I should have just stuck with the yellow here. So I would take my 5.5, and this will be kind of squeezed in here, but 5 and 1/2. It's my first number. And 3 or 7 and 3/10. I got 7 and 3/10. And then I would have, and then just 8/8. So that's my last fraction, is 8 over 10. And I'm going to add all that up. Okay. And so 5 plus 7 is 12. And then my lowest common denominator looks like it's going to be 10. And I would start adding them. Okay. So that's a couple of examples of story problems and addition. Okay. Now, let's just focus for tonight. If you want to write a couple of these down here, these are keywords that I just got through talking about. Okay, and this can help a lot if you start getting used to, what do the keywords mean? Okay, so for tonight, just as you're taking notes, all I want you to do is I want you to write down the keywords for addition. Okay. Very often when it's a story problem and it's the last sentence of the story problem, and there's a question mark in that last sentence, that's the one you're looking for, is a question mark. Look for one of these key words here: to total, or altogether, or plus, or combined, which kind of means put together, right? These are key phrases or words that you're going to see in a typical addition story problem. Okay. Now, for the sake of time tonight, I will send this slideshow to you so you can copy down the subtraction, multiply, and divide keywords. And there are other ones besides these, but these are ones to watch for. So again, if you're taking notes or if you're just thinking in summary, when you get story problems, here are some 3 secrets. Secret number 1 is, if you can, physically take every number. And by the way, a little secret here. Sometimes it'll spell out a number like 4. Okay. There were 4 people who were each 2.5 inches tall. That's pretty short people. How tall are they all together? Okay. If they spell out a number like the number 4 here on your paper, okay, on my paper, here's what I'm going to do. I'm going to write down 4. Okay. But just watch for that, because sometimes story problems will spell a number out. but on your paper, write it as a number. Okay. So that's story problem tip number one, is to put the numbers on paper. Story problem tip number two, look for the last sentence of it where there's a question mark is, because that's the actual sentence that's telling you what you're supposed to be doing, whether it's adding or next week subtracting or the week after that multiplying and dividing. Okay. And so look for the keywords like total or times or minus or difference, and that'll help you. Okay, what I'm going to do now is I'm going to shut off my recording, stop recording.